Hello everyone! Today on the first episode of Vinny's Chemistry, I will show you how to anodize titanium metal. This is just a piece of titanium that I've been using for tests, and I will still use it in an attempt to try to get darker colors from it. Although this setup might seem a little bit complicated, well, my my entire desk is pretty complicated, but it all boils down to this. So what we have here is just a 50 volt, 250 watt power supply, which is this little AliExpress boost converter that's hiding behind the mess of wires and the jar. And then we also have a 1 ohm resistor to measure current, and also a current clamp meter. So that's the meter, and that's the resistor, this little shiny aluminum orange thing. And then there is a jar with a piece of titanium connected to the positive side of the power supply, and a piece of aluminum connected to the negative supply. And there it is. The aluminum is that little piece of metal that's in there, and it looks like some of the stuff might have shorted out, but I'm not completely sure. Um, and the and Notice that it says Epsom salt water. I have some Epsom salt dissolved into this water, otherwise known as magnesium sulfate heptahydrate. Uh, you don't have to use Epsom salt. I just used it because it's relatively soluble in water, and because it doesn't have chlorine in it. If I use normal table salt, then a small amount of chlorine would be released, which is not good because chlorine is kind of dangerous. It's getting some current there. Okay, well we and also because this is water, a small amount of hydrogen will be produced, which isn't ideal in a setting where you have a Tesla coil and a space heater. But well, anyway, here is my piece of titanium, which already has some nice colors on it, and let's connect it up to the positive electrode. And yeah, maybe this isn't the best idea. Okay, so I have wrapped a piece of extremely bad quality soldering wire around my titanium ingot in an attempt to hold it better, and it's probably still going to be just insanely terrible, but let's see if it'll do anything. So, it's bubbling. It shows 330 milliamps of current flowing through this water, and most of it is flowing through the solder, but there are plenty of bubbles forming, as you might be able to see. This view is absolutely terrible, but I think most of that current is actually flowing through the solder. If I just do the titanium, then only 20 milliamps of current is flowing. Well, it maybe just needs some time to do stuff. Let's just let it sit for some time. Okay, maybe the use of solder wasn't the best idea because some of these parts have turned black. Who knows what that could be? Uh, anyway, let's just try to do this directly by hooking it up to an alligator clip, and then just holding it and see what happens. So it says says around 70, 80 milliamps of current is flowing. That's not much, and besides, the meter probably isn't really that accurate. And I mean, I see a color change, but not a very drastic color change. Let's see if we can get this. If we can get a more drastic color change just by letting it sit. Milliamps of current are flowing through the water. Now the titanium has been colored. So, you might be able to notice after drying this off that the titanium has now changed colors. So, if you can see just a bit, the lighting is absolutely terrible, but this this part is still the original yellow. Titanium is normally just a silvery white like most metals, but it was colored. It was already colored yellow due to prior testing. This area has now gotten a little bit purple, and there are some blues poking through here. And then if we go on the back side, there, oh my goodness, you cannot see anything, but this area has turned yellow. This area is more purple, and there is blue in this area, so that's nice. Titanium is a pretty colorful metal in this regard. That's because it is really possible, it is easily possible to grow a thin layer of oxide on the surface, and because this layer of oxide is a couple hundred nanometers thick, which means that incoming light will interact with itself when passing through the oxide. It's kind of like a mirror where there's a thin layer of glass and then the actual metallization is on the bottom. It's pretty similar to this, except the glass is just metal oxide. Um, and because the thickness of that layer of glass is very similar to that of light. Some colors will constructively interfere, and some colors will destructively interfere. So you get yellows and purples and blues and rose gold, and it's just nice colors. And in fact, if you were to blowtorch this, then it would have a similar effect by growing a thin film of titanium dioxide on it. And titanium isn't the only metal that exhibits these properties. Iron can do the same thing, and I think niobium can also do it. A bunch of metals that can grow thin layers of oxide can do this. Anyway, that's about it for the first episode of Vinny's Chemistry.